Hello, hello. So, YouTube is telling me I'm live. Not sure about that right now. Oh, I didn't turn on the speakers. Okay. I think there's a delay in the stream as well. Let me see if I have all my... I could be talking to thin air. Let's see. Oh, that's a huge delay. Hi, Flaming Burrito. Oh, you can hear me. Thank you. Awesome. I was waiting for that audio check. Thank you so much. Awesome. Okay. Is there an echo? Is there any echo around or just doing a quick audio check? I think there's a huge delay. I gotta like figure out these YouTube settings. I will never be able to figure this out, even if my life depended on it. I'm so bad at this. Well, I'm gonna continue until someone tells me that there's an echo, and then I'll start debugging the audio. But today's topic is on food simulations. I had so much fun with these vellum grain simulations and flip viscosities. It was just so much fun. No echo. Awesome. Thank you. So let's see. Well, first I'm gonna start off with a few talking about a few things about designing these simulations to make it look real, to make your food look real on the screen. So there are three key elements that you need to know when you're designing these simulations. The first off is visuals. You have to have, which is something I actually dug into in pretty good detail in the previously posted long form video on textures, where I used image projection texture painting. That's a mouthful. To create those really, really realistic textures onto your geometry. And one of them was the strawberry that really turned out really nice. I'm just gonna launch it up. Let me use the GPU. The strawberry turned out really nice. Yeah, I think there's a huge delay on between the stream and because I think I turned on normal latency just because this is 4K. I needed a bit of buffer ingestion. A bit of buffering between the server and me. I was a little worried that it'd be choppy. It might still be choppy because I have the worst bandwidth in the world. I used to stream at these odd hours many years ago just to get the best quality bandwidth, but then there was like 0 people at the really oddest hours. But since then, the bandwidth has improved slightly. Still not the best in the world. But we'll see how this goes. You guys should tell me if you like the 4K. Like, I could just not go with 4K and just go with HD. And that probably improved the bandwidth. And then I wouldn't have to do this long latency. But anyways, visuals is one of the key elements in trying to when you're coming to design your food simulations. For example, as I was mentioning, the image projection texture painting, that really brought out like this strawberry is CG, but it will take you like a moment to realize that. Like it looks, after someone looks at it for like a moment, a few, maybe 3 seconds, or maybe just 1 second, maybe they would know that it's fake. But it would take a moment. Like that's how. And this only took like 5 minutes to texture paint. In what I was explaining in the long form video and the previously posted one, in the recently posted long form video on textures, and that's where I go more deeper into texture painting and how to get that realistic look really quickly though. So it's not something like photogrammetry. You need light setup and scanning, and you may need an hour or two. This texture image projection painting, such a mouthful, it took like 5 minutes, but there is a downside. If I turn this guy around, you'll see that there's stretching on this side. Now in my long form video that I posted, I talk about a few tricks on how you can overcome these issues, like you can paint over this part. But I just wanted to show you that image projection texture painting has its downsides. It has disadvantages as well. I still can't pronounce your name. Strahindra. Sahindra. I'm so sorry if I butchered your name. Welcome. Arnold Finch. HD is just fine. And audio is a bit low. Oh, audio is a bit low. I can do. I can turn up the gain. How's this? I turned it up just a bit. Because the thing is rather sensitive. Okay, well, not, but it's really low. Oh, it's really, really low? Oh, let me see. I don't know if that did anything. Let's see. Testing. Oh, okay. So OBS is telling me it's better. Oh, I can even hear it a bit more here. Okay, since there's a delay, I have to like wait for everyone. Okay, I'll just keep talking. Tell me if it's still, the audio is still a bit quiet or low. I turned up the gain and I turned something else up. I don't know what I did. Thank God I'm not in broadcasting. It's not really my thing. But visuals, like as I was saying, visuals is really important. It helps sells your render. It's a huge part in selling your render. Flaming burrito, thank you. The voice is fine. Awesome. It's good. Awesome. Okay. Arnold Finch, that's good. Awesome. Okay. Now there are 3 key elements that I want to talk about. In like I said, in the visuals, it's sort of covered in that previous video, so I'm not going to dig too deep into it. I will show you a few renders that wasn't in the video. So first of all, I'm going to talk a little bit about design, and then I'm going to get into the technicalities of the simulations. In the vellum grain simulation, the obstacles that I encountered, there's so many obstacles, mostly in the jittering, how to stabilize the vellum grains into something that you can actually use, because the vellum grain simulation is nice and fancy and all, but in the end of the day, you want to transfer that simulation onto a geometry where you can actually pull apart like the grains, like the cheesy effect or a creamy effect. Like you want to transfer that simulation or convert the simulation into a mesh that you can actually render out. So in the end of the day, that is the goal. The jittering was one of the obstacles that I had so much trouble with. And I'll talk a bit about the flip fluid viscosity, which is super fun and very easy to manipulate. It's very, very fun. But first, a few words on design. Just because that's really important too, to get the look and feel that you want the audience to see. You want the audience to see something on the screen, and you want them to love it so much that they want to, like, one, they have to think about, oh, is this real? Like, it has to look visually, it has to look real. And then you're trying to sell the look. You're trying to sell the taste in this case. Sahidra, is that vellum sim or flip? Both. What are you referring to? I'm going to talk about both. Flip fluid viscosity and vellum grains. Let's see. Jamal, flip, grain. Jamal. Okay. And okay, the next element. So visuals is one thing. The next element is shape. Going back to this. Oh, I was going to show the chocolate, right? Sorry. Got sidetracked. This chocolate turned out pretty nice too. This was something I threw together last night really, really quickly. It's texture material from Substance, what do they call it? The Substance 3D Asset Library. So this, believe it or not, is just a grid. Actually, let me pull up the project. Then I can show you it's actually just a grid, and I want to show you the difference between the grid and doing a single chocolate square, like a single chocolate square like this. Because in the purpose, I was trying to, in the end of the day, I was trying to convert this into an RBD so I can break it apart like a chocolate bar, like that tasty, you know what I'm talking about, those commercial ads with those chocolate bars, and you break it apart, you see it, the debris, chocolate debris bounce on the screen. Oh, I have too much. Okay, let me move all this stuff. So just a quick thing on this chocolate bar. This is a displacement, the one that you saw in. This one is a single grid. Let me show you the single grid. Hide that. It's this, which is, it is a box, but I'm actually only using the top side. The bottom side, I was trying to make it a solid, but you can see how flat this is. So all this displacement is coming from the height map. And let me go into the Karma render so you can actually see what I'm talking about. Give it a second. Give it a moment. Come on. There it goes. Okay. So that grid becomes this, all from that height map. Let me just dig up the height map. RBD, export textures, top, height map. Oh, it went to the other screen. Okay, this is the height map. So that grid, or this displacement, can only happen in Karma. I mean, the results are awesome. I know there's that bottom part, because I was trying to make it a solid, so the bottom is a different chocolate material. Let's ignore that for 1 second. I really should delete it. This is not very useful to me in an RBD simulation, just because it's a grid. There's the displacement information is not available to me when I'm cooking the RBD, when it goes into the RBD solver. Because when you're inputting it into the RBD solver, it's just this. It's just this flat piece of geometry. There's no way for the RBD solver to detect the collisions that happen at the top. At this top part. Or it's gonna look weird. It's gonna look overlapping. The pieces are gonna overlap when the collisions start to happen. So that's what I was working on last night. But texture, like this really sells it. This is one of the key things I wanted to talk about. Visuals, how to sell the look. This really sells it. Visuals, textures is very important. And also shape. Well, shape is very easy for this chocolate bar. It's just a rectangular or square-like shape. I'm just gonna pull up the strawberry. The strawberry has a nice simple shape, which made it very easy to create in Houdini. So the strawberry was sculpted. It was not really sculpted. I used 6 soft transform nodes to create the strawberry shape. And then I would have a geometry to paint the strawberry texture on. So shape is important to help sell the look. Visuals. And there are some foods that you look at, like you see a Taurus, and you immediately think of a donut. So when you're designing your food renders, it's important to have visuals. It's important to have shape. Try creating the shape without the texture first. And then if you can sell the look, if it looks like the food without the texture, you're halfway done. Because once you put the texture on, it even sells it even more. There are other things, like if you have toast or like sliced toast, there's like this. I was making French toast the other day. I didn't have the time to image project this. The idea that I had in my mind was creating toast, 2 toast sandwiches, or 1 toast sandwich, and cutting it in half, and then putting the cheese in the middle and pulling it apart. That was the idea of the project. I ran out of time. I didn't have the foresight to expect that the vellum grains simulation would take so long to stabilize the motion. That was unexpected for me. So you can expect more improvements to be done to some of these renders. So the last thing I want to talk about is just the motion of your food. How does the food move? For example, the cheese, as I said so many times, the cheese is stretched. So once you see that creamy, stretched, cheesy string, you immediately think of cheese, even without the texture, even without color. Just the shape and the motion alone, like this, you can think of as cheese. I mean, this is pretty rough. This is one of my experiments. That's because I have like a huge, let me get my arrow program. A huge, what do you call it? Blob here and a blob there. And it's stretched up just because that's simple to test. But what really sells it is that if I look at this, too much stuff on the screen. If I look at this, whoa, that was unexpected. Well, if I look at this, just the lines, it'll give you that cheesy effect already, just because the motion looks like that cheesy string effect. I just wanted to replay this. Okay. It'll give you that cheesy string effect because we recognize that. So these are some of the key things you need to focus on. Things that people will recognize right off the bat. It'll help sell the look of your render. And of course, the visuals will do the rest, the remaining rest. It's a huge part. The visuals is a huge part of it, but shape and motion really pushes it to a new level. And these are some of the experiments I did. This is the strawberry one. Okay, let's go back to this. The jittering, I had a lot of issues like here. If you look at this guy over here, you'll see that he's going crazy. Just gonna replay it one more time. This guy goes crazy, it goes nuts. So that affects the render in the end of the day. Like, look at those shaking effect. If you look, focus on this, it goes nuts. Like, all these are going shaking all over the place. This one is done with the particle fluid surface. You can see that it's not as convincing just because of the shape isn't that the shape of this geometry is not following the motion path. It's not that stringing shape. It doesn't look like the cheese stringy or creamy cheese. It looks like, it does look like water just because it's the particle surface node that was meant for water. So this does look like liquid. But I was experimenting with different ways on how to convert the vellum grains into something that I can actually render out and it looks like food. And these are more experiments I did. This is converting the flip fluid, playing around with the flip viscosity and animating that. So this is the animation. So you can see the viscosity being color coded over here. So the red is the highest viscosity, which makes the liquid really thick and it doesn't move as much. The lower the viscosity is the purple, and you can see that it's moving a lot faster. So it creates a melting effect. It's actually, the viscosity is actually being animated from bottom to top. So it has this piece of, it's supposed to be a piece of butter. This, as it melts downwards, the top part of the butter gets lower and lower and lower, and more of it turns into a lower viscosity. Now you can see that some of this is being sent, it's flying off over here just because I was trying to speed up the simulation by adding a force to push it downwards and outwards. So it's going, I want to use my arrow program, but it doesn't seem like it's drawing on top of this. Let me, okay. Oops. So I added a force. Let's see if that works. Oh, okay. That's actually pushing it everywhere, like outside from the circle, from the center of the circle, and is pushing it outwards in all directions from the center and down, so that I was putting pressure onto the butter so it would speed up a little faster. When you're doing, I did discover that if you are simulating flip fluids and you're trying to render that out, the best way to render it out is using procedural materials in Karma. That way you don't have to worry about UVs. It is very complex to assign UVs in flip fluids just because of the complex motion of the flip fluid. Now let me pull up my tart. Oh, I had that somewhere. I had the tart. Oh, here it is. Okay. Okay, this tart. Now you can see that. Okay, I'm going to stop right here. So you can see that it's this animation was simulated in flip fluids and then transferred onto this tart. Now this tart, it was photo scan. It was used, I used photogrammetry reality capture and did a 3D scan of the tart, which turned out great. But when I used flip fluids and transferred that simulation over onto this tart using the point deform, it is quite tricky. You can see that it starts to, and I'm trying to hide it using the camera angle so you don't see it at the back over here, but it's starting to deform. It's starting to suck itself back in. And that's because of the flip fluids. As it melts downwards, the particles are getting really close to each other and the point deform is getting very confused and it doesn't know how to transfer. It's getting confused between the top flip particles and the bottom flip particles and doesn't know which one's which and how to transfer that motion onto the geometry. It's magic butter. Flame radio. Yes, it is magic butter. It's flying everywhere. Someone actually mentioned to me on Discord that butter doesn't look like this in their back in their hometown. So that's something I don't know. This is the butter that I've seen in all those ad commercials, those TV ad commercials. I mean, I would think that this is an obscene amount of butter to put on a waffle, though. I mean, that is too much. But it does look tasty. It looks drooling tasty. I usually spread my butter really thin. A really thin layer of butter on my waffle. But it needs to be evenly spread. I'm really picky about that. Like I would have butter that goes into the little holes of the waffle. And I would dig it back out and then spread it even thinner. I'm super picky about that. But anyways, that's my little sidetrack. So those are the 3 key elements that I wanted to briefly talk about. And then we'll get more into the technicality side and vellum grains, flip viscosity simulations, and how to transfer the simulation onto a geometry that you can actually use. That will be the more interesting, and you'll find that is actually the more challenging part. Getting the simulation to work is not as hard as you think, but is not as easy as you want. The challenge that I had was mainly converting the simulation into something that I could use, because all sorts of problems start to happen. And the flip fluids is actually a lot better, just because it's more, I think sidefx spent more time to develop those tools, so there's a lot more features involved that at your disposal that you can use. For vellum grains, I find that it would be really nice if we had like some sort of vellum grains post-processing, which is something which gave me an idea. I'm like, because I spent all that, I spent like 20 to 30 iterations before I could get this effect, this stabilized cheesing effect. Actually, there should be another short clip. Oh wait, yeah, I think it starts playing over here. The stabilized version. Jittering. This jittering. Okay, there is another clip that I want to show you. It's rather important because you might think, oh, it's just jittering. I mean, you won't notice much when you start rendering it out, when you convert it into geometry. That's what I thought, but that's not the case. That it really affects it. Let me just pull it up. This jittering. This is the screenshot that I wanted. Now this is where you can see here, if I start playing this, you'll see that there's these little blobs. It starts to deform, which is not very smooth. It's not what you want. You want a perfect, after I went through like 20, 30 iterations of smoothing and there's a lot of stuff I did. There's like converting it into a volume and then adding more voxels for resolution and adding more topology to the initial grain simulation, I got this smooth so into the point that it's actually not moving at all. And that's one of my goals. That was the goal of the experiment. That may not be the one to sell the actual cheesy look. So you would want sort of a feedback. So when you stretch it all the way up, you want a little bit of bounce at the top. But as for this experiment, I think it was pretty successful just because my goal was to get it stabilized and to learn how to stabilize it. And that's when I realized vellum grains could have used a lot of post-processing nodes, which I actually can put all my stuff together into like an HTA and then release it out to Perk members, because I think that will be very useful for you guys. But that's not the only thing. Not the smoothing is not the only parameter or the only thing to actually do to improve the jittering. There's a lot of other things that you can do too in the simulation itself. Let me just throw this next. Okay, I'm just looking at my notes. The next thing I wanted to talk about was right, and what type of simulation you want to use. This. So what type of simulation you want to use or should be used? For example, oh, this is stuck on top. That's why. Example. This, the syrup pouring of the syrup used flip fluids. That was the best for that. You actually have to experiment around to get the best, to find the best suited simulation for the job done. If you're doing stuff like the cheese, of course you use the vellum grains stretching. Let me check the comments. I almost forgot. One silly moogle. It looks more like margarine than butter. Oh, you are right. That's very good. That's a keen eye you got. I actually do eat margarine, not butter. Just because butter is really, really high in sodium and really high in fat. So I do eat margarine. Flaming burrito. Are vellum grains different from the grain tools used for sand? Do they replace them? I've never used either, but keep meaning to. Vellum grains and vellum sand. It's the vellum grains. It's the same one that I've used. I haven't done a sand scene in a while, but it is the same vellum grains. You can actually use vellum grains to do snow as well. But to get it convincing enough, I find that you need a lot of grain particles. So you need a lot of RAM. And it takes a while to simulate. So I try to avoid it. Unless I have a lot of time on my hands, then I tackle that. But let's see, when else did I use vellum grains? Yeah, that's pretty much it. It was a long time ago where I did this really 10-second clip of a sandcastle, and the grain particles were really large because I didn't have enough RAM. The other time was a snow grain. It looked beautiful, but it cost like 3 million particles. It looked beautiful. But yeah, that was a long, it takes so long to simulate. Oh, circling back to what type of simulation should be used for different types of foods. Beverages. If you have a hot beverage like a coffee, you would use pyro for the smoke to tell the audience that this is really, really steaming hot. Or like the chocolate bar, if it's a solid that you want to use RBD to break it. So different types of simulations. You got to experiment around. I mean, these are one of the more obvious ones, but if you counter something like a little bit more complex, you'll have to try it out. And try it out when you're trying it out. Try it simulating it in the viewport without the texture applied to it. And to actually ask yourself, does this look like what the food that you're trying to create before you actually put the texture on? And once you put the texture on, then it's like the cherry on top of the whole thing. The next thing is what type of animation should be used. And this is something that I've talked about already, like melting, stretching, which is the cheese stretch I'm talking about, and then the spreading, which is the butter spreading, the rising of bread. These are all things that people will recognize right off the bat, with or without textures. The shape and the motion is so universally recognizable that they will immediately think of these things. And these elements will help convince your audience of what you're trying to create. And the last thing is what tools should be used for different types of look and feel. Now, in my in my previously posted long form video on textures, I used Substance Painter and ZBrush to do the image projection texture painting. That was super fast. It was like 5 minutes to do a really quick job. Like this waffle was texture painted in ZBrush's Spotlight in like 5 minutes. Not too bad for 5 minutes of work, but it's only good on this angle. I mean, like I said, in that video, in that long form video, I do talk about different ways where you can overcome that single angle limitation. For example, I showed in the strawberry, you can turn around and start painting the sides with the same texture just because of the simplicity of the shape of the strawberry and the repetitive pattern of the strawberry texture itself. It was possible. So simplicity is the key when you're doing image projection. Simulation driven textures is another thing, is the molding. A molding simulation or a molding render that I did. I should have. Here it is. Okay. This is a molding effect that I did. And this is driven by the Pyro spread source node, I believe it's called. It was one of the Pyro nodes. And that did the spreading for me. And what I did was create, so I already had the waffle texture. I took the waffle texture and the geometry and dropped it into Substance Painter and painted a molding texture on it. But I wanted a slow transition between one to another. Now, if I had more time to put onto this little animation, I would make it the waffle to form as it molds, like sort of sink in. There is a Twitter post where someone did something so amazing. Let me see if I can grab it because it looks so good with the mold, a molding strawberry. Oh, let me see. It just looked so good. I don't know if anyone knows what I'm talking about. It was on I should have had the foresight to like to like bookmark it. Just give me 30 seconds. It's like
Oh, that is a lot of posts. Okay, maybe I'll find it later and I'll post it on the community tab. It's this really amazing strawberry molding effect that was done. It looked absolutely great, very convincing. And there were like ants all over it. I think the lime, he or she, the person that did it, had like different fruits that was rotting. And it looked absolutely amazing. There was like, you can have a lot of fun with food simulations just because it's something recognizable that everyone sees and knows and everyone loves. Come on, everyone has their favorite food. Okay, I can't find it. I should have had the foresight to bookmark it. Flaming burrito. The main reason I asked was because I noticed that there are different shelf tools for vellum and for grains. Did you post the molding strawberry to Discord? I'm not sure. I don't remember. I post a lot of things without thinking. I don't think so. I think because I saw it last night, I probably didn't have time to post it. I just thought, oh, this looks amazing. Because if I had seen it a few days earlier, I would have had the foresight to bookmark it. Right. So different tools that you can use. And this is where I want to go over the chocolate bar, because that goes into different ways that you can texture the chocolate bar and how it's different as well. The different effects that you get. For example, here I have that single plane. It looks great, but you can't put this into a simulation because the displacement, that data, the height data, is only in the height map. And we actually need it if I'm planning to put this into an RBD simulation, I need that data in to be fed into. The RBD needs to know about the height, and you can't feed the height map into the RBD solver. So I tried a few ways of doing this. One, to create a single square. Let's see. Chocolate bar, sorry, this one. One, to create a single square piece and then copy it using the copy and transform and copying it 6x6 so that you would get a 6x6 chocolate bar. This didn't, well, it looked okay. It didn't look like this. So let me put that side by side for comparison. I'm just gonna grab that. So just so that you can have this side by side for comparison. This material looks way better, but it is a flat plane. This one over here, this is the single chocolate square. The one on the left is a single chocolate square using a copy and transform to create the 6x6. Now you can start to see, I did try to play around with the material in Karma to get like the lighting a little bit different, but you can see that there's a pattern. Every chocolate square is exactly the same, even the reflection. Here you have a little bit of difference just because this material, this in substance, has a bit of noise. It's a variety. It has more variety for every single square. It has different reflections. Even the pattern, this little scratching, I guess you can sort of do here as well if I turn it around. You turn every other one around, you could start doing it. So I would have to multiply by 2 so you get spread a bit more, and then do 3, and then we can do this live. Oh no, I would need this one. Okay, let's just do one strip. Let's do 90. And then copy this over. But I would have to move it a bit over. BB box 0 DX size. Yeah, I think that should do it. And let's see what this does. Oh, sorry. I was trying to merge this. Alt. So select two nodes. Hold down Alt and drag it. Sorry, let me just move it up. Select. Hold down Alt. Drag it out. You'll get a merge. So that shortcut is very handy. Now I'm just going to replace it with this. I'm just going to see how it looks like. Give it a second. So that does look significantly better because there's a little bit more variety, but let's see. If we put this side by side, I don't know if it's just me. This still looks a lot better. So it is different. There are different ways to texture it. But if you want to send this off to the RBD simulation, this one will be, you're going to have to make this one work because this actually has displacement data to send into the RBD solver. As opposed to this one, it's just a flat grid and it's relying on the height map. Now, there is another way that I tried doing this because I wanted the best of both worlds. I wanted the displacement, this physical displacement, so I can send it off to the RBD solver, and I wanted this quality. So I tried. Now, let me put this back together. There was another way I tried to do this. Oh, I have to remove this. 6 and remove the 2. Okay. And that's creating the 6x6 and then throwing then UVing it again. So I could get this whole thing into one UV square. So let's take a look at the UVs. This whole 6x6 is now one UV square, as opposed to what I had for this was one chocolate square taking up the entire UV square. So instead, I had to reapply the UVs again, but it was not as, but I didn't want stretching, or want to avoid as little stretching as possible on the sides. So I had to flatten it back down. So that's why I have this rest here. That's why I have this rest here. So I could remember what it looks like. Remember these positions, these rest positions, so I can return it back. And that's because I'm going to do is a flatten. So really here, I'm flattening the top, flattening geometry. In the comments, the Hyman, I am so sorry if I butchered your name. Hi, pro player. How long have you been in this career? As in VFX? Not a day in my life. Whatever you see here is whatever I do. It's more of, well, it started off as a hobby. I don't know if I ever can make it into the real VFX world. I hope one day, maybe. But the market looks pretty bad right now. But yeah, I've never done this pro. I've never done this pro. Whatever you see on whatever content I put out is whatever I know. I learn as I go. it would be cool to see a half-opened foil wrapper with your logo. Ooh. Ooh, that's a good idea. A bubblepins branded digital chocolate bar that no one can resist. And I could put strawberries on top. And then melting ice cream. I've been meaning to do to make a waffle with melted ice cream on top. Not digitally. I mean like in real life. In real life. Like that actually tastes really, really good. I had it somewhere. I don't know where I had it. At a coffee shop, I think. And there was this steaming hot waffle. And then they just put a scoop of ice cream on it and it would just melt on it. I mean, you have to eat it fast though, because it melts really quickly. I don't like it melted, but I like it. I like the taste of having a cold ice cream on top and then the waffle, crunchy waffle on the bottom. In real life, in digital, like it'd be nice to do it digitally too. I think that would be really cool. I want to do a melting ice cream render, but I couldn't find the right shader. Like I do have an ice cream shader. Sorry, I'm getting sidetracked again, but I gotta show you this ice cream shader. It looks really awesome. It's not from Houdini, sadly, so it doesn't really work well in animation, and that's one of the obstacles I had. Oh, come on, open. Oh, there it is. Okay. Doesn't this look awesome? This shader looks awesome. It's in Blender. It was a add-on I purchased. I don't know when I purchased it. I think I purchased it when it came out because it just looks so good. So I exported the rubber toy geometry from Houdini into Blender to test out the shader, and it looked great, but not when it's melted. The shader is not meant for animation, sadly. So I haven't figured out a way to make melting ice cream look like melting ice cream yet. My guess is that the melted parts, or the one with the parts with this surrounding this blob, this melted blob part, has the lowest viscosity, and I probably need to do like a texture change, very much like the molding waffle. And I need some sort of melted ice cream texture looking image or thing flat on it. And I think that would solve my issue. And that would make this more convincing. Because this doesn't look like melted ice cream. It looks like a pile of... I mean, it looks like ice cream. Just because the shader's so awesome. Not because of what I did. The bubble bar. The bubble bar. Flaming Burrito. Is she reading YouTube? Yeah, I am. Sometimes. I would read it occasionally. I am reading the chat. Flaming Burrito, she is, but there is delay. Yeah, and there is. It doesn't help that there is a delay on the broadcast, on the stream, and also I take a while to talk, and then I look at the chat. So there's a huge delay on top of another delay. Is this ice cream? Whatever. Yes, it is supposed to be ice cream. The shader looks awesome. But the melted ice cream doesn't look as great. Okay, there goes my little sidetrack. So that was one of the reasons why I don't have a melting ice cream render yet. Anyways, back to the chocolate. There's a different way where you can actually UV this, is that I flattened it. So we began with this. This is my displaced one, where I can have the actual displacement data in preparation to feed into the RBD solver. Flatten the top down and then apply a UV flatten. So I could get, let me get rid of that square. Okay. And then I would get this, the whole UV square to cover the whole 6x6 chocolate bar. That was only just to get the UVs to look right. So I would have minimum amount of stretching on this little, on the side of the squares. Then I have to restore it back to what original state. And this is just offsetting the edge. So these two here, let me ignore this. You can see that, okay. You can see that it's just stretching the sides, because I noticed when I feed this into the chocolate bar, so I'm using the whole 6x6 chocolate bar material from Substance Painter, because I want the best of both worlds. I want the nice render coming from the actual full material from the substance asset, from the substance material. And I also want, like, they're a bit different for each square. So I needed the whole UV square to take up that whole spot. And I should be able to feed this into an RBD solver. And I noticed that the sides here, the sides are a little larger. So this now becomes a problem of fitting the actual display, the sizing, matching the size to the texture. This becomes a problem matching the size to the texture. So I'm still a little off. As you can probably tell, I don't know if you can tell, you can see that, I don't know if you can tell, like this part is not matching up with the texture. It's not matching up with the texture that great. Like you can see here, the chocolate comes up here and there's a bit of beveling. That's coming from the height map. But I have to match the square, each chocolate square, to the same size on the chocolate square on the texture material. So there's different ways of texturing and playing around with things. It's not just throwing a texture on and just because you have an awesome texture and just throwing it on. It becomes, it's different for every scenario. Please fix the delay. Okay, but the problem is because I'm streaming 4K. Without the delay, it may be a very choppy. I will try that next time. I'll try that for the next one. I'll use make the broadcast a little shorter, like do a shorter live stream, and then try it with. Or I could just go without the 4K. I gotta stop pressing on the 4K. I've been trying to get everything 4K, pushing all my content out in 4K now. I don't know why. The obsession with 4K. So when are you making melting ice cream? When I find the right texture. I don't know. I have ice cream shader, but I don't have a melted ice cream texture. That is the issue that I have. I mean, I didn't put too much time onto it. I should. That will be the next thing that I'll work on. Yeah, it's not matching the texture, but it's too good. Yeah, it is really good. I really like that shader. Kudos to the creator. It's like really, really good. I feel like getting ice cream right now, just looking at this. They have many flavors too. It's not just the strawberry. I think they had like chocolate. And then you can adjust the swirls. I really want to create, this is a procedural shader in Blender. So this is all procedural. You never would have guessed. I looked into it. Like you can look into how the creator created it by diving into the material in Blender, because this was a Blender shader. I wish we could create this in Houdini, is what I was trying to say. But sadly, Karma materials don't have the same math nodes in comparison to Blender. Blender has an awesome material system. They have way more material nodes. Not material nodes, texture, noise nodes, and math nodes that really help material development. Okay, the perfect texture is waiting for you. I hope so. I will find it. I will find the perfect texture. Or maybe recreate the ice cream texture from scratch. Although I may not be able to get that quality. That looked awesome. I may not be able to get the same results. It would be nice though. Okay, there goes texture painting. And texture painting is very useful. Sorry, I'm just trying to pull something out while trying to say something. Is the elephant walk. You can apply texture painting on almost anything. So something can be like so out of this world. This elephant is from an example, built-in example in Houdini. I can actually pull up the project so that I can show everyone where I got it, because I don't remember. Hello, hello? I don't know what happened. The mic just broke down. Can anyone hear me? And of course there's a delay. Man, I really do gotta fix that delay. Testing, testing. One second is now over. There's a delay. So 1 second plus the delay. Man, I gotta fix that delay. Maybe I should just give up the 4K. I don't know what happened. The mic just shut down. But your audio's not coming. Audio's back. Awesome. Finally. So sorry. I don't even know where it got cut off now. I just kept on yapping. Oh no. Audio's back. I'm so sorry for that. I don't know what happened. The mic just shut down. The wire was plugged in and everything. All I did was unplug the mic and plug it back in. That's all I did. Oh well. I wonder if it might have overheated. It is a little hot in this room. Well, I don't know where I got cut off, but I'll just repeat just a small part of it. This is where you can get like the elephant geometry. So everyone has access to the elephant geometry. If you throw down a joint. Now tell us about this elephant. If you throw down a joint capture, what was it? Joint configure capture. Which one was it? Joint geo. Attach joint. This node. Throw this node down. Click the help button up here. It has to be launched up there in order to load in the example file that is built into your Houdini. So everyone has access that has Houdini. Click the example link. And once you click this load, it will load an example file into your Houdini. And within that example file it contains this elephant, which I used to paint my strawberry on top. And then it started, and it also has a walking animation that comes along with this example to create the really bizarre strawberry elephant, which I really like. This elephant model is really nice. Then you get this effect. And they got this animation, this walking pose, just by manipulating. If you look through the example, I think it's an example for KineFX. They got this walking, not by animating it. Well, yes, by animating it, but by manipulating the original walking animation, this original walking animation, changing that up by changing the rest pose, which I found amazing. So this is quite complex. This is like certain rig controls, the old way of doing it, not the Apex way. This is the old KineFX way, because this example is quite dated. It predates the Apex. I believe it predates the Apex. This is rig controls. And they're manipulating all this to get the walking, to get it on the 2 feet. And you can see that this is plugged in. This is manipulating the rest pose and not the actual animation. So this is very clever. to get this. They're actually manipulating the the rest, in order to change the four-legged walk into a two-legged walk, which is really cool. If you're into KineFX, you'll find that cool. But the purpose of me, I was just reusing this elephant because this model is awesome, and I was just painting the strawberry texture on it to experiment what I can do with image projection texture painting. You can paint on almost anything, something that's so ridiculous, and just make people laugh. This is something that is those vertical videos, those TikTok videos that I never watch, or the short form videos, the what is it called? Short videos. It's one of those things. This is very content that is meant for that. Let's see. I'm gonna read the comments. Now tell us about the elephant. How the elephant is red. Is it new generation of elephant? Have you made this elephant yourself or bought it somewhere? No. As I said, it's from the example file in Houdini. So I'm gonna move on. I think that's where I was cut off. I was like talking about that, and then the mic just shut down. That is the first time that ever happened. I think it's just getting really hot. Either that or I'm running out of RAM. Maybe I should close some of these windows. Turn this back to CPU. Let's see. The waffle was the molding that I talked about. Oh, let's move on to viscosity. And that comes the fun part. Now this was supposed to be my ice cream simulation, but like I said, I couldn't get a texture. I couldn't find a texture that I was satisfied with. Oh, let me put some color on it. Okay. So this never made it out to the public. I don't think so. Yeah, I never put it in the trailer just because I didn't have a texture to put this on, but this is great. This effect will be awesome for those melting effects. Like if you have something hot poured onto something cold, because this is melting in the middle and it's actually dipping into the center. So the purple is the lower viscosity. The viscosity attribute is being animated. And I don't need that many frames, so 1 second. I'm gonna go 150. Just because the computer is gonna crash. Okay, the viscosity is being animated from the top to the bottom this time. In the melting butter on the waffle, it was animated by the height, because the bottom part of the butter had the lowest viscosity, and I was putting a force pressure pushing the butter down, so the top part of the butter particles would eventually get lower and lower, and once it get to a certain low height, it would animate the viscosity. That's how I did the butter. This one is doing it the other way around. It's doing the top to the bottom, and I'm actually not adding a force to it. I'm actually animating it from the top to the bottom, like animating the viscosity. Let's see. Let me just show it to you. I'm using the Pyro spread here, this one, Pyro source spread node, which, let me show you, color. So this is spreading the attribute from the top. It's like it was meant to spread fire, but I'm using it for all sorts of craziness. How much RAM do you have? I have a lot, but let's see. think it was 128. I think I have 128 gigs. But it's DDR3 RAM, so it's the older RAM. Because DDR4 is way too out of my price range. And a lot of this is using GPU now, though. But CPU is important. It's still important in Houdini, especially when you're doing fluids. Tell us about your PC specs. I have a Threadripper 3rd edition. That's the one with the 24 core one. I forgot the number. I have a RTX 4090. I believe it's 128 gigs of RAM, DDR3 RAM, not 4. So it's quite slow. I have a lot of hard drives just because these projects and all the experiments and testing that I do, it takes up gigs for each project. And even then, I still don't, I run out of space a lot. So I have to delete a lot of I never keep cache data. So the geometry cache data always gets deleted. The image sequences that get rendered out gets deleted. Because all I need to do is keep the actual final rendered animation. I don't need to keep the image sequence. What else? Yeah, that's about it. I don't know what else about my computer. I did do, when I installed the Threadripper CPU, I did do a blog about it. Just because it was so different. Installing the Threadripper is very different than installing any other CPU that I had ever did predating that. Because the Threadripper is actually a rectangular shape, which is very different from your the ones that I was used to, like the Pentium ones or the older Intel ones. Those were like a square. I think it was this. Let's see. Okay, found it. So it's like this. And it was super nice. They have like a caddy that is built on the CPU. So you can insert it very easily. That was very thoughtful. And it has this nice large case, which is very kind of waste, but I can see the need for it to protect this. Just when it came out, it was kind of pricey. So yeah, this plasticness is actually necessary. Otherwise, you're going to damage all these pins. Some of the pins would get damaged during shipping. This is very necessary. But what is more interesting is how you spread the thermal paste, because the Threadripper is it gets a lot hotter than your normal PCs at the time. At the time when this came out, the heat specs were a lot higher. The temperature heat specs were a lot higher than than the ones that I was used to, the old Intel ones that I was used to. So I needed a lot of thermal paste. I couldn't take a picture of the thermal paste spreaded on just because it was so messy at the time. What I did was open a new tab. Okay. What I did was I put painter's tape all around it, and then I used a piece of business card, like something that I could throw away, and squeezed the thermal paste onto the middle part of the CPU chip, and then spread it like butter all over it. Just because I had painter's tape surrounding protecting the other surrounding components, I wouldn't have to worry about making a mess. I was more concerned about having evenly spread thermal paste, because the temperature was quite an issue for me, since I didn't buy a liquid cooler. I'm using a fan cooler. At the time, I bought this guy. At the time, people were saying that these heat pipes were doing better specs than the liquid coolers. I don't know about now. I mean, my PC is kind of old now. Yeah, and I had to like rebuild my old machine because I didn't have the foresight to link my Windows at the time. And I was like, oh, my Windows doesn't recognize the new PC. So I had to rebuild the old one. This was fun though, rebuilding the old one, because I had already used all the parts for the new PC when I bought the new one. Later make a video of my PC. My PC is kind of old though. I don't know if anyone would watch that. The newer one is, I don't have money to upgrade again though. The newer ones are getting pricier and pricier. This, I don't know how long I can use this one for, because Houdini simulations they're RAM eaters. They're CPU eaters. However, as I find that I get more experience working with these simulations, I have more ways of optimizing the scenes and more little tricks here and there, and you get used to, you learn to love the Houdini crashing. I don't know if that makes sense to anyone, or if anyone believes me. You learn to love Houdini in all the quirks, good and bad. It was really fun rebuilding the old machine just to link my Windows, because it didn't work when I was when I built the new one. I reused old parts from my old one, so the old one was not functional at the time. I took out the case, so I didn't have a push button, I didn't have a start button or anything, all just to link my Windows, because I didn't want to format my drive. I wanted to reuse the drive. I can't believe I still have it, because I thought for sure I would lose it. It was like buried in all my rubbish. And I hooked that up. I hooked this little button up to the motherboard on the old PC just to make it boot up. That was fun. That was something I had never done before, but it was actually not that hard. It was just harder trying to find the manual for the old PC, because I had like threw it around. Like I had things all over the place. But once I found the manual, it told me where the jumpers were, and all I had to do was plug in this push button into the jumper wires, into the jumper, what do you call it, headers, and it booted up. And yeah, more problems. But then eventually I got it running. I managed to, all this was just to link the Windows. So the new PC, I could get the new PC running. That was I don't know why I went through all this. All this just because I didn't have the foresight to link my Windows ahead of time. Anyways, that was my little distraction. Let's see. Old is gold. Wow. But still, I want to see your PC. Whenever you free, then please make a video. Yeah, I could. I don't know what's there to talk about. I was pretty... I've never done any like benchmark testing on my PC. It's not as fast as it used to be. Like when it came out, it was like the latest and greatest thing. AMD has since pushed out a lot of fancy CPUs ever since. I wish I had the cash at the time to upgrade to, because this is the 24 core one. They do have another one that's 64 core at the time when I bought this, but I didn't have the cash for that. That was like twice as much as the 3960, which was already killing my budget. And then now they have one that is comparable to the Epic. There's a Threadripper 4th edition with 128 CPUs, cores, 128 cores, that is comparable to the Epic system, which is I don't think the Epic is a commercial CPU because all the parts, I think it uses industry RAM and all that stuff. But yeah, okay. Wow, we're going into 2 hours in, and I still just touched on viscosity. Does anyone still want to hear more about viscosity? Or is everyone just too tired? I haven't even gone into grains yet. I think I planned way too much material. Here, let me jump into grains versus viscosity. Let's see. Don't worry, you will become famous in a few days, and it will be not because of your... one can dream. I'll keep dreaming that. Let's see. Oh, let me finish this off. So coming from this, which is a flip fluid with animated viscosity. So again, just to recap, just because I have so many sidetracks, I used the Pyro source spread node, which is a Pyro simulation, which it just spread. It's meant to spread fire. So I'm using that to drive the viscosity. And then this is the effect that I get from animating the viscosity parameter. It's loading. Animating the viscosity parameter using the Pyro source spread. So this is the effect that you get, which is really nice because it's melting in the middle. I don't know if you saw that. So it sort of melts in the middle here. I mean, these are really large particles. I'm going on with, let's see, 0.03. So these are really large particles. This is not a high quality simulation. It was an experiment I was trying to do, but I couldn't find the melting ice cream shader. So I gave that up. But anyways, this melts inside, which I really like. It could be used for if I had another simulation that's pouring liquid from here, from the top. I can animate where the water pouring or some sort of fluid that's being poured up top, like a hot fluid, and have that transfer viscosity attribute values to this sphere shaped flip fluid and have it melt like that. I think that would be really cool. And then Pyro for the smoke to complement the whole scene. I think that would be really nice. Now I took this melting effect and I used a point deform node to transfer it to another sphere, to a perfect sphere, like a geometry that has UVs. Now that's the important part, because UVing these flip fluids is not easy. Just because of the complexity of the animation and the motion of each flip particles, you're going to have a hard time assigning UVs to it. But this is what I wanted to show you. If you have a perfectly, but this sphere is a lot easier to UV. All I did was apply a UV project on polar, using a polar assignment. And this creates really nice UVs right off the bat. Now, the next question is, how do you transfer that simulation, that viscosity melting simulation to this sphere that I have perfect UVs? Not perfect UVs, but really good UVs. Because these good UVs will mean a lot to me when I throw on a texture. Here I'm just throwing something, the monkey texture, just to test it out, just to see how it would look like. The point deform does everything for us to transfer the motion of one animation onto another geometry. So we're transferring the animation from the flip fluid and extracting all that motion data and throwing it onto another geometry. This, one thing you need to know about the point deform is that the particles cannot change. You have to have the same number of particles. So the flip fluid here, the flip simulation, is not deleting anything. It's not reseeding. So you need to turn off your reseeding, or just don't turn it on. So I just want you to notice this. I'll just keep this here. Okay. Let me put an arrow here. Okay. Okay, and I'm gonna play this. Now it's not deleting any particles. Sorry. In the flip fluid, how you can waterline reseeding. So the reseeding, this is the, oh, let me get rid of this. So this is the part you have to pay attention to, the reseeding. Normally you would turn this on if you want to keep the volume of your fluid simulation. So sometimes if you're melting something, the fluid would spread, or in real life, fluid may expand or contract. So it might shrink. Reseeding gives you the ability to maintain or shrink the volume of, I think you can shrink. It's usually you can maintain the volume. So this would actually create more particles on the fly, like to maintain the volume of the flip of your fluid. You can play around with the surface oversampling. I turned it off so it would be more compatible with the point deform. It's redoing the simulation. This worked out nicely, but it doesn't always work out nicely. The point deform doesn't always play nice. That's one way. So I'm running out of time. It's going 2 hours. Vellum grains. I might just skip vellum grains. But what I really want to talk about is grains versus viscosity. When would you use grains and when would you use viscosity? Viscosity in flip fluids affects how the fluid flows, where lower viscosity fluid flows faster. As we can see in the butter example, the bottom part of the butter has lower viscosity. It melts faster, and the top part stays intact because it has a higher viscosity. Let's see. So viscosity directly affects how fluid flows. Grains is more like deforming geometry has complex deformation of geometry. So grains can give you the ability to create new shape that flip fluids cannot. Like you can't create that stringy effect in flip fluids. It would be really hard. And also flip fluids, it's easier to mesh. It's converting the flip fluid into a geometry. It's much easier thanks to like the particle fluid surface node that accompanies with the flip simulations. Grains doesn't have that. So you have to think of your own way, or you have to be creative in converting that grain simulation into something that you can actually render out. And the reason why I don't want to start on vellum grains is, one, because we're running out of time. I didn't think the other topics would take so long. The grain simulation, getting that jittering to stabilize took a long time, and that topic is really long. I don't want to start it right now because that's going to go on for me yapping for at least another hour. So maybe I'll save that for the next time. Okay, so I'm going to... I know there's a huge delay in the stream, but does anyone have any questions? I'm going to start ending it off. Other than, I know Damon. I don't know how to pronounce your name. Sorry. Diamond. I hope I got it. I hope I got your name right. I know you wanted a review of my PC specs. My PC is not as interesting as you think, other than the fact that I have a lot of hard drives. A lot of cheap hard drives. They're all 5400 RPM, so it's not the 72 RPM one. 7200 RPM ones. Those are a little bit faster, but they're a little pricier because I use up a lot of hard drive space. Yeah. So here comes the awkward moment where I don't know what to talk about. I'm hoping to take this to a new level and actually create one of those, maybe create a fake commercial, a food commercial. If you've ever seen one of those behind the scenes for those food commercials, how they created them, I actually couldn't find ones on that was created using CGI, but I found a lot of references for behind the scenes for food commercials that are shot in real life. They used all these really cool equipment, like robotic arms, slow motion cameras. What else did they have? They had a lot of crazy props that are not edible. So most of the things that you see in TV ads for food commercials are not edible. Reading the comments. Can this liquid work on diamonds? Yeah, sure. It depends on the shape of the geometry. Because the diamond, I'm assuming a diamond doesn't have much convex. Your diamond geometry doesn't have as much convex surfaces. Like it's not, it doesn't have any holes like the torus. Those types of shapes of geometry is perfect for the point to form. It's the geometry where it has like, it dips in, it divots in, or there's a hole or a lump, or what you call it, like the tart. The tart has a lump on the top. It's not flat. Those ones are quite hard to... I find that the point form struggles with. Flaming burrito. Bubblepins computer is secretly transformer. That would be cool. It could just transform into a newer PC and upgrade itself. Save me so much money. Yeah, you're right. Yeah, I wish. One could imagine. Well, if nobody has any questions, I'm just going to end it off here. I'm super thirsty, super tired. Well, I hope everyone learned something today. I do apologize that some of these renders are not as good as I wanted them to be. I just ran out of time. I hope I can show you more polished renders in the near future. I'm gonna keep working on this, and my goal is to get those food commercial ad qualities, because the image projection gave me such powerful visuals. Like the strawberry and the tart turned out great. Well, the tart was photo scanned, but the waffle and the strawberry turned out so great, and it didn't take much effort. Like it's within a time budget that I can actually afford. If it takes like a week just to texture it, that becomes an issue, because then you have to work on the simulation, and you have to work on the design, the motion design, and you have to work on everything. It's not just the texturing. That's just one part of the game.